Intel doesn't like the rules of the game anymore, so it has an announcement. It has changed the rules. There are actually some interesting things that came out of Intel's latest Intel Accelerated event, but the core of everything that we really need to go over is that node naming conventions as they exist now are subjective at best and bullshit at worst. And this is actually the same mentality that Intel CEO Pat Gelsinger opened up the Intel Accelerated event with, albeit with more polite phrasing for a multi-billion-dollar CEO. And it's one that we need to talk about too. So 10 nanometers may sound like an objective measurement because it has units and then a number, but that's a common trap to fall into. Units and numbers don't always mean things, at least not when marketing gets involved. The meaning can differ between Intel, TSMC, Samsung, and anyone else with a fab. As with the old megahertz myth, or the 8-core FX CPUs would prove, there's a significant motivation for whichever company has the better number to brag about it, regardless of whether better is in the positive or the negative direction in terms of its numerical value. They'll find a way to make it the best. And historically, the company that has the so-called worst number will just pick a different number instead, as with processor names and clocks. In totally unrelated news, Intel has a new naming scheme. That's right, it's dropping nanometers and instead bringing all the numbers down by one category to conspicuously match TSMC's numbers. Let's talk about that. Before that, this video is brought to you by Thermal Grizzly. Thermal Grizzly's Hydronaut and Cryonaut thermal pastes are high-performing thermal interfaces for use on CPUs and GPUs. You can bring an old card back to peak performance by repasting it and doing preventative maintenance, and Thermal Grizzly's Hydronaut is ideal for water cooling and air cooling for new and old cards alike. Cryonaut paste is one of the top performing pastes for extreme overclocking with CPUs and GPUs and has been used in several world record scoring machines. Learn more at the link in the description below. Much of Intel's announcement is rooted in this change. It's coming down to getting rid of the 10 nanometer naming, the 14 nanometer naming, and all the various pluses and sundries attached to it, because this no longer makes Intel look good. There are some valid reasons to want to make this change, and Intel does go over them. The main one is that X nanometers doesn't really mean what it used to mean. It's not a strictly objective measurement anymore, and the fabs all kind of determine how they want that number to be applied to their own process. And so this makes it very confusing for a consumer in that no one actually really derives any value from it, and we just have to look at performance. And that's fine. It certainly benefits us if everyone just has to look at performance. But it would be nice if the numbers meant something more uniformly. Of course, as we can see from any other industry, look at cars, for example, or bikes or whatever, there's always going to be a losing party when you have objective measurements. And that's when the objective measurements are no longer objective and they change into different measurements. So it seems like that's an unavoidable problem in almost any industry that exists today. Intel's trying though. And the first thing it's trying is to not look too obvious in what it's doing, which is bringing the numbers down. So Intel 10 nanometer, for example, sort of becomes called Intel 7. You have Intel 7 nanometer becomes Intel 4. There's no nanometer at the end of it, so they've fixed the problem. They've gotten rid of the nanometers thing that doesn't mean anything apparently, but they've kept the number and then they've reduced it to be lower than TSMC's or AMD's or minimally equal to it. And this is where you start to question what's the motive really. All of Intel's currently released products will retain their existing names. The i7-1165G7 woefully will still be called the i7-1165G7, which is a name that we'll never be able to say without a script. And that's from the Phantom Canyon NUC we reviewed a few months ago. It will also remain marked as 10 nanometer SuperFin in Intel's database. And the Intel 11900KB from the NUC we're currently reviewing will remain marked the 10 nanometer process node in its database. Meanwhile, the 11900K we reviewed earlier this year will remain marked 14 nanometers. And also, by the way, so too will the Intel 6700K, 14 nanometers, that we reviewed in 2015. So if it seems like this is maybe confusing, then you're not alone, because we just named 3 processors that start with 11 and are on 3 different process nodes by Intel's database, and also are not changing with these changes that are being announced today. And then we've named 2 with 14 nanometers that are 6 years apart. Clearly something needed to change because this doesn't look good. Node names haven't communicated any useful information, at least from Intel, for years, and even Intel has been inconsistent in its use of the full enhanced super plus good names. Intel stated, quote, "We are refreshing our lexicon to create a clear, consistent, and meaningful framework." But it seems like clarification may be an excuse rather than the true motivation for Intel's change. Intel's new naming convention is basically the same as the old one, except with better sounding numbers that definitely don't sound like a reactionary move to the rest of the industry, leaving them behind. 10 nanometer superfin, sorry, got that wrong. It's 10 nanometer enhanced superfin. We don't normally leave those mistakes on the script. I feel like this one maybe illustrates the issue that Intel is trying to solve though, so we're gonna leave that in there. 10 nanometer enhanced superfin will now become Intel 7. You can stop waiting for the units at the end, there are none. This evokes a comparison with TSMC's 7 nanometer, clearly. It's obvious that this is what Intel's going for, is a one-to-one comparison. Now, in the past, analysts who are far smarter than I am have stated that 10 nanometers on Intel is similar to 7 nanometers with AMD's architecture and TSMC's process node. David Cantor is one of those who suggested to me previously in an interview that Intel's 10 is maybe more comparable to someone else's 7. And as far as we can tell, that's true. So maybe there's something there to equate, or on Intel's side, to equate its process down to 7 and try to make them direct numbers to numbers comparable. But yeah, ultimately, what this says to us, being not experts in architecture and process technology, is that maybe we do need a different metric altogether, or something that is objectively comparable, because if we're just changing the numbers because one manufacturer feels like the other one makes a product which is similar to this manufacturer's product with a bigger number in the name, which is worse, then there's a problem, because they're just going to keep changing the numbers until whoever is perceived as behind, whether or not they are, is now perceived as equal. So that's how it's always going to work. Anyway, it may be appropriate that Intel 7 is comparable to TSMC 7 nanometer, but at the end of the day, this implies a generational improvement over 10 nanometer superfin, which maybe isn't the case. At least Intel directly addressed this in the presentation, saying that, quote, "This is equivalent to a full node of performance gain. As a result, we believe that Intel 7 is an appropriate name to help customers understand the kind of competitive performance being offered by the node." As for 7 nanometers, and we'll put some text on the screen to help this make sense, 7 nanometers becomes Intel 4. 7 nanometers plus becomes Intel 3, and so on. And here's why we're down the middle of this. So our team is fairly skeptical when it comes to big public-facing events like this, because the companies behave differently in them than they might in a press briefing where it's more technical. Ultimately, the naming is a problem, yes. Nanometers with a number attached to it doesn't mean the same thing between each fab, and maybe there's a misconception that it does, and that therefore 7's always better than 10, or 10's always better than 14, when in actual fact, maybe it's a little bit more nebulous than that, depending on the architecture and who's making it. But if Intel just wanted to address naming concerns as a first-party concern, it could have done a number of things. One of them is it could stop naming its products stupid things that no one can keep up with, but that's apparently not the topic for today. It could have also used something like Intel Alpha, Beta, or Delta, Intel X, Y, or Z, and instead it decided to stick with numbers. It also decided to conspicuously reduce all of the numbers. Very obvious that the numbers have gone down now, and then drop the suffix at the end. So, did we solve it, Intel? I don't know. We're still using numbers. I guess we solved at least one problem. To be clear, we understand why Intel wants to make this change. We just wish that they would be less obvious in making it so reactionary to what the rest of the industry is doing, and maybe present it a different way. Anyway, once we're out of the our nanometer number sounds bad danger zone that Intel was in, Intel switches back to using units again. Maybe reinforcing the fact that this is all reactionary. It moves then to Intel 20A and Intel 18A. Intel says this, quote, "marks the start of the Angstrom era." Or as we would put it, we're running out of integers. What do we do? This leads to some fun quotes from Intel. One of them was when Intel was discussing things, it said, well, we'll just play it for you.
Almost annual cadence of new process technology from Intel 7 to Intel 18 in 4 years.
So basically, Intel has taken a bell curve and flipped it. And that's why we're going from 14 to 10 to 7 to 3 to 18 to 20 in the naming. There's also a meaningful changeover from the final FinFET product, which is Intel 3, to the first RibbonFET product, and there is some actual technical information we'll go over here too. That would be Intel 20A, the first RibbonFET one. That's a more technical conversation, but Intel also said that, quote, our new names are based on key technical parameters that matter to our customers: performance, power, and area. Now, we can't speak for everybody, but we here are particularly excited to see what the performance, the power, and the area of 7 is. Intel painted itself into such a corner with the 14 nanometer plus clownery. That's a real name, by the way. That we'd be poking fun at them no matter what at this point. But it'd be at least a little better if the new names either A, communicated clear generational or tier differences, the way that the Core Series naming does, which has its own problems, but whatever, or B, corresponded to some real physical aspect of the hardware or production process. Intel has been baited at this point into playing by AMD's or maybe TSMC's rules, and it's obvious. The bottom line is that none of these names have anything to do with real-world performance. It's maybe somewhat ironically because Intel's the one that keeps beating this drum about real-world performance and real-world benchmarks while going against benchmarks.
You can literally see it.
It's amusing to make fun of Intel for taking years to hit 10 nanometers, but it's never mattered what the process is called. Intel could have found some excuse to call its products 10 nanometers a decade ago, but it wouldn't have made the CPUs really any different. Benchmarks will prove the real value of these products and how they compete with TSMC silicon. After all, as Pat Gelsinger apparently likes to say,
and as I like to say, it's easier to be number 2 in the bike race than it is to be number 1. You know, and you're able to just catch up much more quickly by exerting less energy. And we're really leaning on the learnings that we have from ASML and the deepening relationship that we have with them.
It's really bizarre. He's right. It's very easy to be number 2 in a race when only 2 parties are racing, because you literally can do nothing. There can be 2 people in the bike race, and all you have to do to be number 2 is sit down, and you've done it. You're second. Good job. This is such a weird thing to say. He said something about how you don't have to work as hard to catch up if you're number 2 in a bike race. We understand what he's trying to say. He's trying to say it's easier for a company to follow someone else's innovations, but what he's saying doesn't make any sense unless your bike is physically tied to their bike. Let's move on. Actually, he's basically implying that you don't have to try to be almost number 1. Except in a bike race, if you're not trying, you will literally only fall farther and farther behind each leg of the race. So, okay, no, seriously, let's move on.
Back to you, Steve.
There were several other embarrassing moments in this, whatever it is, like around 15 minutes and 20 seconds, where Intel mentions 3 technologies that they say they lead in or have led in, and then the presenter moves on while the animation in the background shows 10 nanometers. Oops, not sure if that was a mistake or not, but we have had enough of just watching Intel's presentations and then pulling out all the ridiculous things they said. We have now 2 episodes on it. And for this one, we're just going to move on to covering some of the actual news because it just seems like Intel's trying to get that attention now. So let's cover some of the news. Once upon a time, the industry did use physical dimensions of a transistor. That would be something like gate length, pitch, etc., to determine what it calls a process node. And the rise of non-planar transistors, so 3D transistors that we use today, relegated the use of the word nanometer and its attached units as nothing more than a semi-arbitrary marketing tool that competing foundries would then use to bludgeon each other with as they tried to figure out how to tell consumers that theirs was better than the others. To be clear, foundries still use nanometer numbers, but again, it's in a very commercial marketing sense. And A nanometer number loosely refers to a class of transistors rather than necessarily an objective hard measurement that is the same in what it refers to between all the fabs. So when we say a class of transistors, when you're talking about TSMC N7 or 7 nanometer or whatever, really what you're talking about is TSMC's 7 nanometer class of product. The silicon that is on this class doesn't necessarily mean anything else. And the same goes for Intel 14 nanometer, where you're talking about a class. And to be fair to Intel, it's done a lot more with 14 nanometers than it ever deserved to. So really good engineering work by the people who were able to string that along for as far as they could. Because if you look at a 6700K versus today's CPUs, there's a pretty big difference in what came out of it. But they're still late. So ultimately, the names are this. Intel 7, this node was previously referred to as Intel's 10 nanometer enhanced superfin. It's an intranode optimization of 10 nanometer superfin. Intel cites 10 to 15% performance per watt gain. And as we already knew, it will be based on the continued FinFET optimizations. Intel 7 will apply to Intel products such as Alder Lake, Sapphire Rapids, and Intel's Xe HP graphics silicon. Intel 7 will debut for client products in late 2021 and for the data center around Q1 of 2022. Intel 4, this node was previously known as Intel 7 nanometer. Intel had already disclosed before the name change that Intel 4 will lean heavily into extreme ultraviolet lithography, or EUV. Intel previously announced a successful tape-in for a Meteor Lake compute tile that uses Intel 4, and Granite Rapids-based compute tiles for the next Intel Scalable Xeon will also use Intel 4. Intel 4 will apparently offer a 20% performance per watt gain over Intel 7 and is expected to enter volume production in second half 22 for product shipping in 2023. If you are familiar with the concept of math, you'll know that 4 is not a 20% change from 7. So it's still based on basically nothing. And you can just look at these as a class of silicon, just like you look at TSMC 7 nanometer. Intel 3, based on how Intel is describing this node, we believe it's what Intel was once referring to as 7 nanometers plus, also going from 4 to 3, and the new naming suggests that this is more of an enhanced node rather than a fully new node transition, similar to TSMC's node advancements such as N7P to N7 plus, and so forth. While it seems to overlap with Intel 4, there's evidently enough here that Intel named it Intel 3 rather than Intel 4 Plus or whatever. Maybe they just don't want to get into that quagmire again. For Intel 3, Intel cites an increased use in EUV lithography, an 18% performance per watt gain over Intel 4, a denser HP library, reduced via resistance, and increased intrinsic drive current. Intel says Intel 3 will be ready for products in second half of 2023. This next one is where things get simultaneously more interesting and more vague. Intel 20A. With Intel 20A, Intel is seemingly targeting 5 nanometer class chips and claims this is the beginning of the Angstrom era of semiconductors. Intel is referencing the Angstrom metric unit, which is a non-SI metric unit. Intel isn't providing a lot of details on Intel 20A or how the word Angstrom here is being used, just like nanometers, same problem. For reference, 10A is equivalent to 1 nanometer, 20A is 2 nanometers, and so on. And so Intel is also going to finally debut its version of GAA FETs with Intel 20A, known as RibbonFET. We'll discuss RibbonFETs more in a little bit, but Intel 20A will also mark the arrival of Intel's version of backside power delivery, the PowerVia. Intel 20A is slated to be ready in 2024. Although off the roadmap, Intel 18 Angstrom, of course, was also mentioned. So Intel briefly mentioned 18A. It said it'll include refinements to Intel's RibbonFETs and PowerVia. Intel said it will be working closely with ASML. That's L, not R. ASML is the one that makes the equipment that makes silicon. R is the, well, we won't get into that. So ASML will receive the industry's first high NA, or high numerical aperture EUV production tools. Intel 18A is set for 2025, and this is when Intel says it will regain manufacturing leadership. So quite a ways out. As stated previously, Intel is finally ready to talk about its use of GAA FETs, which are expected to replace FinFETs as the transistor of choice. Intel's RibbonFETs are Intel's proprietary implementation of nanowire and nanoribbon GAA FETs in the same vein as Samsung's MBC FETs. This will actually be Intel's first new major transistor architecture overhaul since 2011. and Intel showed off diagrams of a 4-stack nanoribbon design, which are surrounded by a gate. So it is actually a major change for Intel, despite all of how easy they make it to make fun of all the marketing.
Thanks, Steve.
PowerVia is powering Intel's RibbonFETs, and the big change here is that Intel calls this a backside power delivery interconnect. So PowerVia connects to the backside of the transistors rather than routing the power around the front side and around the signaling circuitry. So according to Intel's various research papers, backside power delivery, which is what PowerVia is doing, confers benefits such as reducing the supply voltage drop, so IR drop. It also apparently improves the signal routing via the front side of the transistor thanks to the absence of large power delivery wires and circuitry. And Intel says that it also lowers interference. So this design imposes its own challenges as any designs do, but that's one of the main changes that Intel went over in its Intel Accelerated event. Also, EMIB was discussed, so that's the Embedded Multi-Die Interconnect Bridge. This has been around for a little while now, but Intel announced that Sapphire Rapids will be the first data center product using the technology, which signifies how far Intel has come in getting EMIB functional, getting the packaging process right for EMIB. Earlier this year, actually, images leaked of a 28-core Sapphire Rapids Xeon with an early A2 stepping, and a subsequent delidding revealed 4 CPU dies or tiles under the IHS, presumably interconnected with EMIB. Intel also announced it would show a second-generation implementation of Foveros, which is its 3D chip stacking die-to-die technology. That'll start on Meteor Lake, which we have mentioned previously in news videos. It'll also use Intel's I hate these names, process for the compute tile for Meteor Lake. And finally, there's Foveros Direct, which is more similar to what TSMC and AMD are doing for 3D V-Cache, actually, than anything else. So AMD with TSMC for its 3D V-Cache CPUs, the one it showcased a couple months ago, a big deal of what they were doing, they moved away from micro bumps and the way they were basically fusing the silicon together of the cache on top of the rest of the CPU was copper to copper direct contact. And so Foveros Direct will see Intel move to a copper to copper wafer bonding technique as well. And this is rather than using traditional solutions like thermocompression wafer bonding, for example. So that's the big news. Intel, you know, it'd be nice if they could just say things without getting the level of BS involved that they do, because there's some real technology here. Intel says that it's blurring the boundary between where the wafer ends and where the package begins with Foveros Direct. It will allow for bump pitches at 10 microns and eventually sub 10 microns. And TSMC, by the way, it's similar process. We chip on wafer, as they call it, as part of 3D Fabric branding. So that's the news from Intel. The naming was the big thing. You're going to see Intel 7 pop up. It sounds like on Alder Lake. We're not sure if that'll be on Alder Lake as desktop parts or not, but it sounds like that's the plan. Just know that this number, basically these numbers, they're all made up at this point, and we'll keep using them to refer to a class of product. So basically a family of product, just like when we talk about TSMC N7, N5, whatever, it's referring to a class. Same thing here. Just don't directly compare them to each other. Instead, you can look at performance numbers, which Intel both wants and doesn't want you to do, depending on which product it is. We've gotten mixed messaging from them on that one, too. So anyway, that's it. Thanks for watching. Subscribe for more. As always, you can go to store.gamersnexus.net if you'd like to help us out directly, or patreon.com/gamersnexus for some extra videos and written blog posts and things. And post a comment below letting us know what you think of all this. We'll see you all next time.